Slow, slowly.
Volume is slow.
Hmm. Sir, 1 minute, sir. If anyone talk na, that will take this system voice. So don't talk loudly. That YouTube participants will think that way.
Can we start with that?
1 minute.
This is the main post. You can log in using your phone, sir. Log in using your phone, unmute, and you can talk. Easily you can sit there and read, no problem. Once you click the link, you can log in.
Sir, in between don't disturb us, sir. Come on.
You do not
Swarnandhra College of Engineering and Technology. Unleash your potential. Build your career here. Godavari Delta in Andhra Pradesh, with its finest soils and pleasant waters, is the richest region for its age-old traditional and cultural heritage. The Vasishtha Godavari, a tribute of river Godavari, flows fluently with all that vibrant iridation spreading along its banks.
Our college was established in 2001 by the Vasishtha Education Society to produce global, competent and dynamic professionals, creating Center of Excellence in Technical Education for Empowerment. Apart from curriculum, we train in the latest technology like data science, VLSI, Python, full stack, Java full stack, SAP, process integration, ABAP, FICO and ERP.
Swarnandhra College of Engineering and Technology in Narasapur of West Godavari, vicinal to Vasishtha tributary, carries the baton of such a rich heritage with its dedicated efforts and support in imparting up-to-date, latest, ultra-modern, futuristic mode and phase of engineering education and tech knowledge.
We at Swarnandhra give importance to intersection between theory and practice, passion and present for good technical and practical knowledge. It makes our children ready for the industry.
With its more than 2 decades of untiring and uncompromising quest, empowering the next generation of engineers, Swarnandhra College of Engineering and Technology had unleashed the potential of thousands of enthusiastic students with its engineering program. Yes, Swarnandhra College of Engineering and Technology is pushing the boundaries of technology. Are you ready to join it? Do you want to forge your own path with its top-notch engineering curriculum? Don't you want to be part of a community of innovators, creators, and problem solvers?
Swarnandhra is a place where thinking out of the box is contagious, and it is also a place where ideas inspire change.
Here you are welcome to the prestigious Swarnandhra College of Engineering and Technology, where excellence meets innovation.
Swarnandhra College of Engineering and Technology is a well-maintained campus with green orchard in beautiful ambience, very conducive.
2,000 computers are available with LAN connection and an internet facility of 800 Mbps bandwidth and Wi-Fi signals spread to all the nook and corners of the campus. A separate computer center with digital library and a central library with 60,000 volumes and 9,500 titles are available for the students with hands-on experience in their respective fields. Workshops of all branches, namely mechanical, electronics, computer science, robotics, artificial intelligence, nanotechnology, are equipped with latest machinery and tools that help the students to hone their practical skills.
Swarnandhra constantly motivates its students towards fulfilling learning experience.
There are 5 separate hostels available in the campus of Swarnandhra College of Engineering and Technology. Hygienic mess and food courts. Round-the-clock security. CCTV surveillance in the campus. Departmental stores and ATM center serve the needs of students here.
We are adapting latest technologies in the syllabus and curriculum periodically with the support of industry professionals.
Your admission into Swarnandhra College of Engineering and Technology makes you transform your tomorrow with the skills you learn today. Because you're stepping into their engineering program molds your creative absorption into technological passion. The UG courses in BTech ranging from civil, mechanical, electrical and electronics and communication, computer science, information technology, artificial intelligence and machine learning, CSE Data Science, CSE Cybersecurity, CSE and Business Systems, Artificial Intelligence and Data Science, Robotics, PG courses such as MBA, MCA, MTech, Structural Engineering, Power Electronics, CAD/CAM, VLSI Systems Design, Computer Science and Engineering, Thermal Engineering, Communication Systems, Diploma courses like Electrical and Electronics, Mechanical, Electronics and Communication, Computer Science and Engineering, Artificial Intelligence are all dealt with equal and efficient range of commitment and euphoria. Swarnandhra College of Engineering and Technology not only just offers all these branches and courses, but also encourage its students to work on live projects and collaborate with their peers, giving them a taste of real-world scenarios.
Another college have an outcome-based education, choice-based credit system, open electives for the academic enhancement. We are all well qualified and experienced faculties involved in quality education and R&D activities.
The faculty members of Swarnandhra College of Engineering and Technology are not only knowledgeable but also passionate about teaching. They ensure that the students are equipped with the latest technical knowledge and are prepared to face the challenges of the industry. Swarnandhra College of Engineering and Technology paves the path to discover the power to innovate with its centers of excellence. The CM's Skill Excellence Center, IBM's Center of Excellence, Indo-German Collaboration Arc Laboratory, Intel's Center of Excellence, VMware Center of Excellence Laboratory, Dassault Systems Lab, Cisco Networking AWS Lab, Nanotechnology Research Laboratory, and IoT Incubation Center. Swarnandhra College of Engineering and Technology believes in the holistic development of its students, where in wide range of extracurricular activities that help students to develop their leadership skills, communication skills, and teamwork abilities. Fabulous auditorium that hosts various events and guest lectures throughout the year, and sports facilities such as cricket, volleyball, basketball courts are top-notch, providing opportunity for the students to participate in variety of sports and fitness activities. IEEE, ISTE, CSI student branch chapters are formed among students and they function quite effectively in Swarnandhra College of Engineering and Technology. The college has the permanent affiliation to JNTU Kakinada, is approved by AICTE, acquired an autonomous status from UGC, also accredited with grade A by NAC. Placement trainings are offered to the students of Swarnandhra College of Engineering and Technology. From first year onwards, and 100% placement assistance is a promise carried out accustomed. Training and placement department has been functioning in the campus since its inception.
Placements are the art of our institute. Our placement record is great and consistent, with the average salary of 4 lakhs and the highest salary of 11 lakhs from the past few years. We take utmost care about internships and projects. We take this opportunity to request you to enlist our institute with your list of colleges for the campus recruitment.
Students are equipped with the most sought-after employability skills to make them industry-ready. Many trained students are placed in reputed MNCs like Cisco, TCS, Wipro, and CTS, etc.
Good evening, sir.
Good evening, sir. Shall we start?
Good evening.
Sir, okay, sir. Very good evening to one and all present here. I am Dr. R. Sanjeevi Kumar, Professor. With me, Dr. R. Lalit Narayana, Professor, Department of Mechanical Engineering and Technology, Andhra Pradesh, and coordinator of this faculty development program. On behalf of Department of Mechanical Engineering, Swarnandhra College of Engineering and Technology, Andhra Pradesh, I welcome our today resource person, faculty members, research scholar, participants from various institutions for this 6-day online faculty development program on recent advancements in mechanical engineering and its application. Now, it's my pleasure to invite Professor Dr. D. Bhanuprakash to introduce our Day 2 Session 1 resource person. Sir, please.
Good, good evening to one and all. It's my immense pleasure to introduce Dr. Nagendra Muniyandi, Senior Lecturer, School of Engineering, Faculty of Innovation and Technology, Taylor's University, Malaysia. SAR's academic qualifications are Diploma, BTech, MTech and PhD from University Tun Hussein, Malaysia. SAR's area of expertise, which includes energy management, measurement and verification, energy optimization, computational mechanics, biomechanics, hard facing. SAR has published 20 research papers in various international reputed journals. SAR's research projects are integrated optimization, analytics, and and Communication Console as co-researcher in 2021 to 22. Energy Audit Conditional Grant Project as a project leader since 2018 to 2021. Fretting fatigue delamination of HAP for hip implantation as co-researcher since 2018 to 2020. SARS awards and stewardship includes diamond recognition under Low Carbon City 2030, a challenge from Special Ministry of Energy, Science and Technology, Malaysia. SAR is as a professional member of Professional Engineer Board of Engineers Malaysia since 2021. Member in the Institute of Engineers Malaysia since 2021. Professional technologist in Malaysia Board of Technologists since 2019. Certified Energy Manager in Asian Center of Energy since 2019. Thank you for giving this opportunity, sir.
Thank you, sir. Now I hand over the forum to our today resource person. Sir, please.
Thank you very much for the warm welcome and a very good evening from Malaysia. Right. So before I proceed, let me share my screen. Yeah.
Okay, sir.
Is it my screen is visible?
Yes, sir.
Yes, sir. Visible.
Yeah. So my voice is loud and clear, right?
Yes, sir.
Yes, sir. Sure.
All right. Thank you very much. So let's begin our session. So it's a great honor and pleasure to be here with you all to share one of the very alarming issue all over the world. Right. So when we talk about the recent advancement in mechanical engineering, I personally believe that this energy management should be an important part of it, because now our world is going towards energy efficiency and also renewable, and all engineers playing an important role to achieve these energy management goals. And today my topic, I personally focus on this energy management because I'm one of the energy management practitioner in Malaysia and also in Asian countries, and especially today in today's topic, I'm going to cover how energy management can lead towards greener universities, right? How to make a campus as a green campus, low carbon campus by practicing this energy management. That will be the main important topic that I'm going to share in the next 1 hour, right? So a small introduction about me. Just now, sir already introduced me. Okay, so basically I'm a academician and also I'm a practicing engineer, and I'm an Asian energy manager. So where I have a quite number of years experience in implementing energy management system in various buildings, and also I'm working in a chiller optimization areas as well. All right. So I don't want to go very detailed about me. So let's proceed with our topic for today. And for today's topic, I'm going to cover 7 main subtopics. So first, I'm going to discuss about climate change and how climate change is affecting us and why climate change is an alarming issue all over the world. Right? And then second, I'm going to focus on the energy technology. And third, sustainable development goals and what is the role of energy management under the sustainable development goals. And fourth, I'm going to focus on the low carbon building. And fifth, sustainable energy management system. So what is sustainable energy management system, and how we can implement that in a building. And then number 6, I'm going to maybe do some sharing on roadmap towards achieving a low carbon campus, right? And then last but not least, I'm going to share a case study. So as a mechanical engineer, so I have a mechanical engineering background, and as a mechanical engineer, how we can participate in this low carbon campus with proper energy management and what is achievable. So that will be my sharing under this case study. All right. So first of all, let's look at this climate change, right? So now, wherever we go, all right, so every countries around the world, they're talking about the climate change, right? And climate change is something very, very serious, right? For example, you can see here, right? So this climate change, as we all know, it can cause flooding, right? It can cause flooding. And then this is one of the studies conducted in China. So it is estimated that the cost of flooding to China due to the climate change from 2016 up to 2035, it is set to cost US 389 billion. So that means climate change is not only damaging, but it's very, very costly. And then climate change also will be increasing our earth temperature or global temperature around 2 degrees Celsius. So it is predicted in upcoming years, okay, it is predicted in upcoming years, our global temperature will rise around 2 degrees Celsius. You may ask me, okay, if let's say we sit in a room, maybe our air conditioning is around 24 degrees Celsius. If let's say I increase if let's say I increase around 2 degrees Celsius, maybe we don't really feel it, right? We don't really feel it, okay? But when we talk about the global temperature, right? When we talk about global temperature, this 2 degrees Celsius rise, it is something very, very serious, right? And it is going to affect many countries as well, right? But then now our United Nations, together with all the developed and developing countries, they have come out with a mission called 1.5 degrees Celsius. Okay, 1.5 degrees Celsius. So what's all about this mission, 1.5 degrees Celsius? Basically, this 1.5 degrees Celsius mission is to keep the earth temperature not rise up until 2 degrees Celsius. The allowable global temperature rise is only 1.5 degrees Celsius. Again, you may ask me, what is the difference between 1.5 degrees Celsius and 2 degrees Celsius? It's just another 0.5 degrees Celsius. But again, that 0.5 degrees Celsius, what it can cause, okay, you can see there's a infographic. So if let's say the earth temperature rises 1.5 degrees Celsius or the global temperature rises 1.5 degrees Celsius, the extreme heat, okay, the heat wave, it will be additionally 14%. But let's say the global temperature rises 2 degrees Celsius. So it will be 2.6 times worse compared to 1.5 degrees. Again, let's say Arctic Ocean free of sea ice in summer. Again, the 0.5 degrees Celsius increment, it can cause the effect of 10 times worse. Same goes to sea level rise. You can compare 1.5 degrees Celsius global temperature rise versus 2 degrees Celsius global temperature rise. So it's almost 10 million fewer people exposed if, let's say, we maintain 1.5 degrees Celsius. Same goes to, still most of the countries depend on the food from the ocean, right? So this temperature rise or global temperature rise, it will decline the annual catch of marine fisheries as well. But again, how much it can be worse? From 1.5 degrees Celsius to 2 degrees Celsius, it is the double the effect. And then the crop yield, reduction in maize production in tropics. We compare 1.5 degrees Celsius global temperature rise versus 2 degrees Celsius global temperature rise. The effect is 2.3 times worse. Same goes to species loss, plants and animals. Again, the effect is, it's double. Okay, you see, just this 0.5 degrees Celsius of increment in global temperature, it can cause double the effect, right? And then finally, decline in coral reef, it will be 29% worse. So that's why this mission 1.5 degrees Celsius is introduced, so that we can combat climate change and we make sure that the climate change doesn't reach the global temperature rise up to 2 degrees Celsius. All right. And then now from climate change, we are going to move to energy technology, right? So we all know that still most of the countries around the world, their primary energy source comes from the fossil fuel, such as coal, oil and gas. So around 84% of global primary energy. So global means we are talking about all the countries, right? We are including all the countries. 84% comes from the fossil fuel. We all know that the energy comes from fossil fuel. It's not a clean energy, right? And from this 84% of global primary energy, 60% contributing towards the global greenhouse gas emission. Again, this is something very, very serious, where this greenhouse gas emission can contribute towards climate change. And then global power demand growth will go up by 100 gigawatts. So that means it is predicted that 100 gigawatts will be power demand growth. But our renewable is only supply 35 gigawatts. I'm talking about globally. So that means from this 100 gigawatts of demand growth, only 35 gigawatts can be supplied from the renewable energy. The remaining 65% still need to come from the fossil fuel. So this clearly confirms that, right? So our mixture of clean energy into our total energy production still not yet achieve what we call the full we call it the full amount to cover the demand growth, right? So that means it's still a very long way to go to integrate our renewable or clean energy into our power demand, right? Now, sustainable development goals. All right, so I think most of us is already familiar with this, right? So there are 17 set of goals is introduced under this sustainable development goals. So previously we know this as a millennium development goals, which introduced from year 2001 up until year 2015. There were 8 goals, right? So after that, United Nations have introduced 17 sustainable development goals. So what is the main agenda of the sustainable development goals is to reduce the gap between first world country and also third world country, right? So to reduce the gap. And we all know that this sustainable development goals is basically we are covering in economy point of view, environment and social community. So we are covering humans, people, we are covering environment, and also covering the economy of a nation, right? And then when we do start the sustainable development goals, it is officially started January 1st, 2016 with 169 target. So now we have 17 goal. So from this 17 goal, each of these goal will be having its sub goals. So that means, for example, let's say goal number 1. So under goal number 1, there will be a sub goal, maybe 4 sub goals or maybe 5 sub goals, right? So altogether under these 17 SDG goals, we have 169 target, right? And what's so special about this sustainable development goals? We cannot achieve one goal alone. So that means all these sustainable development goals should be achieved holistically, because each of these goal is connected and it is interdependent, right? And then how many countries have been participated in this SDG? Almost 190, right? And all these countries currently they are doing data collection and reporting whatever action plan they are taking towards these sustainable development goals, right? And for today's sharing, I'm going to focus on sustainable development goals number 7, which is affordable and clean energy. So if let's say I dive deep into this affordable and clean energy, there are 5 more sub goals, where the first goal is universal access to modern energy, right? Still many countries in African region unable to access to energy. They are still living in dark, right? So to cater or to address those problems, so then the goal target 7.1 is introduced, where universal access to modern energy, right? And then target 7.2, increase global percentage of renewable energy. So just now I mentioned that the power demand growth is 100 gigawatts, but only 35 gigawatts comes from renewable energy. So target 7.2 is focusing on to increase the global percentage. So that means maybe from 35 gigawatts, maybe we wanted to increase it to maybe 50, 70, and one fine day, our 100% of total energy comes from the renewable energy. And then target 7.3, double the improvement in energy efficiency. Double the improvement in energy efficiency. So energy efficiency means we are using something in a very wiser way. We are not wasting, right? We are reducing demand. So all this comes under energy efficiency. And then target 7.4, promote access to research technology investment in clean energy, where most of the research center, universities can play a crucial role under this target 7.4. And finally, target 7.5, expand and upgrade energy services for developing countries. So that means in some developing countries, if let's say you guys notice, their access to energy services like renewable energy, energy efficiency is actually they are accelerating it, right? And if you notice, among these 5 goals, I have highlighted target 7.3. Okay, highlighted target 7.3 because again, this will be our area of interest for today. All right. So before I proceed, let's discuss about low carbon building. Right. So when we talk about low carbon building, or sometimes we know this as a green building, it's not alone energy. Other than energy, we also need to consider the water consumption, how much waste we produce in the building, and the mobility and transportation in the building, and greener and water bodies around the building. Right? Because all this element that I have put it here, it can produce carbon emission. Right? So when produce carbon emission, of course, it leads to a climate change as well. Right? So now by optimizing energy, water, waste, mobility, and green and water bodies, we can go towards the low carbon building. But today, I'm going to cover on energy only. Okay, why I'm going to cover on energy only? Because energy is the major contributor towards the carbon emission. Okay, so before we proceed further, let's look at this water dispenser. Right, let's look at this water dispenser. So until today, so as I mentioned just now, I'm a practicing energy manager in buildings. Right. So when I go and meet the building managers, or when I go and meet the building communities, they still have maybe I will say a limited understanding the difference between renewable energy and energy efficiency. So let me tell a simple analogy. Right. So let's say we have a water dispenser. Right. We are having a water dispenser. Right. And maybe a student. Okay, a student, he feel very thirsty, so he wanted to get some water. So he took the glass, they go to water dispenser, and he opened the tap. Right, he opened the tap, take the water. But before he leave, he forget to close the tap, so the water is flowing. Right, and then a second student came. Okay, a second student came, and he noticed that the water level in this dispenser is reducing. So what he did was, immediately he top up the water. Okay, he top up the water so that the water level can go up again. Right, and then he forget to notice that the water tap is not closed properly. But without noticing that, he just top up the water. Then after 1 hour, he come again to check. But again, he notice the same thing. The water level goes down. Right. So why I'm sharing this? So top up the water is similar to renewable energy. We are utilizing renewable energy. But the step here is representing energy efficiency. So what I'm trying to say here is, without taking care the energy efficiency properly, how much renewable energy we bring into a building is just a waste. It's just a waste. The first thing, okay, in a let's say we wanted to optimize a building, or we wanted to make a building a low carbon building, the first thing we should focus is energy efficiency. So if let's say the energy efficiency is taken care, then the renewable energy will be the next stage. All right. So just now I mentioned, why I'm giving special interest on this energy portion from this low carbon building. The reason is, let's say we look at different standards, different green building or low carbon building standards across the globe, right? So the lead standard from USA, Green Star Australia, Green Mark Singapore, and Green Building Index in Malaysia, all the standards covers on the energy efficiency. For example, under USA, energy and atmosphere. Under Australian standard, number 6 is energy. Under Green Mark Singapore, the first one is energy efficiency. And in fact, in Malaysia, energy efficiency is one of the focus as well. And if let's say we see the we see the weightage, okay, the weightage of each of these element contributing towards achieving a building as a green building. For example, let's focus on the green building index Malaysia. So 35% of weightage is given to energy efficiency. So that means compared to other elements, energy efficiency is given a higher weightage because, as I mentioned earlier, energy is one of the highest contributor towards the carbon emission. And same goes to LEED USA. So USA, this is number 3. Okay, number 3 is around 35%, right? And maybe one of the important thing I wanted to share. Okay, normally when I go to India, right? When I go to India, okay, I normally used to do a guest lecture or sometimes some sharing in India. So now all of us following the standard. Okay, all of us following the standard that introduced by Westerner, right? So they package it as a green building, low carbon building and all that. But thousand years ago, this green building is already in our practice. Our Indian traditional, if let's say we look at our Indian traditional houses, right? So this green building is already in practice. For example, let's look at this house. So there is open space here, right? This open space is to provide a day lighting, a proper ventilation. So it's part of green building again. And then this open space also, we can collect rainwater. Again, it is more to water efficiency. It's part of green building, right? And then there are a lot of other things that we already practiced so many years back, right? But now you see the Westerners, they take from us and they package this and give to us as a green building. Now every one of us need to follow this, right? So this is just a sharing from me. All right. Let's talk about electricity cost in India, right? So from 2010 up until 2025, the average electricity cost in India is tremendously rising, right? The electricity tariff or maybe average electricity cost. Okay, so this is I considered all the state in India and I average it, so it is rising. So that means the more energy that we are wasting, basically we are wasting our money as well, right? And then to cater this, okay, to address this, so what we can do, we can practice energy management cycle. So what are the steps to practice energy management cycle? The first thing, we should evaluate where are you now. So as a building, first thing, there is a dedicated evaluation tool, right? Later I will share what are the tools that we can use to know where the building is standing in the point of energy efficiency, right? Once we evaluate, then we need to take necessary action to eliminate the waste. You see, when we evaluate, we already know that, okay, we already noticed that, okay, there's some wastages happening, right? So we can immediately eliminate the waste. So once we have successfully eliminated the waste, the next thing is we need to reduce the demand, right? So eliminating waste and reducing demand is part of energy efficiency, right? Part of energy efficiency. So once we eliminate waste and reduce demand, then we're able to manage the energy smartly. So that means to manage the energy smartly, we need a proper monitoring system, proper reporting system. This is where we as engineers, we can contribute as well in terms of software development, dashboard development, all comes under here, right? And then eliminating waste and reduce demand, we can contribute in terms of maybe we introduce maybe a new algorithm to make the building run in more efficient way, or maybe a system to make the building consume less energy, right? And then after we're done with all this, then only we can generate your own energy, this is where the renewable energy part comes in, right? So once I done all this, then maybe I introduce solar or wind energy, right? Then again we repeat this process. So this is the basic 5-step. All right, next I'm focusing on the sustainable energy management system. right? So there's a difference between energy management system and sustainable energy management system. So sustainable means basically it is a continuous process, right? And energy management, why we are treating this as a system? The reason is, okay, let's discuss about the place where we are working, right? So maybe we need to come to our university or college at 8 a.m. in the morning, and we need to leave maybe 5 p.m. in the evening, right? Again, the question is, who have said you need to come to campus or you need to come to university at 8 a.m. and you can leave at 5 p.m.? So of course, the top management, right? If let's say they don't set this kind of a working hour, so what will happen? Everyone will come as they wish, or sometimes people won't be coming to campus, they work from home and all that. So that means what they have introduced is a system. When a system is not in place, what will happen is people won't follow a certain procedures, certain steps. So similarly, energy management should be treated in that way, where energy management should be a system rather than just a practice, right? And this sustainable energy management system is basically, it is a process of managing energy consumption in a building. Okay, so how I'm going to consume energy in a more optimized manner, how I'm going to reduce the waste, how I'm going to reduce the demand, all this will be covered under this sustainable energy management system. And again, compared to other system, right? Compared to other system, normally other systems, it works from bottom to top approach. So that means from employee, it goes up to employer. But this sustainable energy management system, it should work top to bottom approach. So that means your top management should decide that, yes, I'm going to go for this sustainable energy management system, and I'm going to implement this. If let's say your top management not into this, then this effort will be wasted. So that's why this sustainable energy management system should be top to bottom approach. And then how to achieve this sustainable energy management system? The first step is to have a good structure and policy in the building, right? And then the next step will be to create awareness among the building community. You may ask me, every one of us already know what is energy efficiency and renewable energy, and how, what's the difference we can do, or what's the difference we can make by just creating awareness, right? So based on my past experience in this energy management, implementing this energy management system, 3 to 5% of energy can be saved by just creating awareness in a building community. So that means by creating awareness, I'll make sure that the building community follow the best practices in energy management, and that can contribute to 3 to 5% of energy saving. This is with no cost, no cost, just creating awareness, which can lead to energy saving. And then under this SAM system, we should have a target, right? Target and proper procedure. Like target means, okay, the next 1 year, I'm going to achieve maybe 5% of energy saving. The following year, I'm going to achieve 10% and so on. We should have a target, right? So now let's compare the energy management system and sustainable energy management system. For example, let's look at this left-hand side diagram. So normally, energy management will be an alarming issue in an organization or in a building when we realize that the electricity cost is higher. So once we realize the electricity cost is higher or the building operating cost is higher due to this energy utilization, so immediately the top management will be focusing on how to reduce the energy cost, right? So once they take the proper action plan to reduce the energy cost, the next thing what will happen is they might change their focus into some other things. For example, in a campus, maybe they focus some other things like the students issue, or maybe some other issues like staffs related issues and all that. Then again, what will happen? The focus on energy management is neglected. Then the cost of energy will be rise again. Then again, we repeat this step. But when we talk about sustainable energy management system, it's all about a continuous monitoring, a continuous effort, a continuous implementation of energy efficiency. So this is what we call as a sustainable energy management system. So once I have achieved the cost reduction, then I monitor and I report that so that I can realize further saving. All right. So what the immediate goals we can achieve by implementing sustainable energy management system SEMS? So first immediate goal we can achieve is conduct training and awareness program. As I mentioned just now, 3 to 5% of energy saving can come from this. And then we can come up with a monitoring and recording system. So that means this is a continuous monitoring and recording so that we make sure that the sustainable energy management system practice is not just a one-off practice, it's a continuous practice. And third, the change of behavior, improved housekeeping practice, maintenance and operation. This is something related to the awareness as well. Right. And what is the long-term goal? The long-term goal is towards reducing a low carbon building, reduce carbon emission, okay, low carbon lifestyle, achieving a low carbon lifestyle. Then to be leader in the sustainability best practices, focusing on a building centric, okay, building centric. So increase the green technology usage and also establish a sustainable carbon management system. So all these are a long-term goal. So the long-term goal, normally it will take 5 to 10 years, but the immediate goals we can achieve within 1 year. Okay, we can achieve within 1 year, right? And most of the time, this immediate goals is not that expensive. Okay, not that expensive. We can easily achieve this. All right. And then talking about the sustainable energy management roadmap. Okay, sustainable energy management roadmap. So what are the steps to achieve this? The first step is we need to evaluate. Like I shared just now. For example, let's say I relate this with maybe I wanted to reduce my weight, right? I wanted to reduce the weight. So before I start my exercise, before I start my diet, what is the first thing I will do? I need to measure my weight so that later on I can compare and I can see how much I have reduced. Because basically energy saving, okay, energy saving is something that we are measuring something that don't exist anymore. It means the energy that I'm initially using or initially utilizing, when I implement some energy saving measure, that energy is not there anymore. So I'm measuring something that is not there anymore. It is difficult to measure, right? So what we can do, we only can come out with a baseline and I compare with the baseline so that I can conclude how much I've reduced. So the baselining is very, very important in energy management, right? But here, the evaluation is, this is a very general type of evaluation where there is a dedicated tool, we call it as an energy management matrix introduced by Asian Center of Energy. Under this energy management matrix, there are a few pillars or maybe a few elements that we can evaluate. Okay, later I will share this as well. Okay, I will share what is energy management matrix and how we can evaluate where we are. Okay, so once we done evaluation, the next step is organization preparation. So this is where I mentioned just now. It's a top to bottom approach. So your top management should decide and should go for this, right? So once the organization preparation is done, then we go to, okay, before we go to the next stage. So what are the items under organization preparation? First, we should have a proper energy policy. Then we should have an energy committee. Then we should set up an energy component. And then we should introduce energy awareness training for the building community. So once we done this, once we done the organization preparation, the next step is implementation of energy conservation measure. So that means I am taking effort to reduce the energy. But before I take effort, I should know where I should focus, which system should be my target so that I can achieve a good energy saving. To do that, we need to do detailed energy audit. Okay, again, as engineers, mechanical engineers, electrical engineers, right, and other engineers, there is a great job opportunity currently a great job opportunity under this energy audit field, right? So once we're done with energy audit, then we can select what is our energy target and plan, right? A typical energy management plan is 3 years, okay, 3 years. So once we have energy target and plan, then we set up a sustainable implementation team. So that means, let's say I'm having 5 programs I'm going to do. First, I want to save lighting, next my air condition, and so on. So for each of this implementation, I will have a dedicated team. And then a technical training. So technical training is more to the human capital development, right? And once we done this, the final stage is system integration. The system integration is where we go for some certification. It can be ISO certification, or it can be I shared just now, it can be a green building certification and so on. All right. So this is the typical energy management metrics tool. As I mentioned just now, it's more like a rubrics. Okay. So as an academician, I believe that you guys are very familiar with rubrics and rubrics. So it's more like a rubrics. So under this energy management metrics, okay, under this energy management metrics, you can see that there's 1, 2, 3, 4, 5, 6 pillars, which is energy policy, organization, motivation, information system, marketing, and investment. Right. So under the energy policy, so if let's say, for example, I wanted to know about your campus building on this energy management. So I will use these rubrics. First, I will check whether there is energy policy or not. If let's say no policy, then I will just tick here, 0. Or sometimes most of the building, they have an unwritten set of guidelines. I'll tick here, right? And then organization. So organization, is it a dedicated team to manage energy, or is it energy management in the building or not? So I think accordingly. Then the motivation. The motivation is not more to the contact between building community and also the energy committee. Right? Is it just a very informal communication from the facility management to the building community, or there is a dedicated channel? Then the information system. Information system is more to, for example, if let's say we go some buildings, right, they display today how much is the consumption, yesterday how much is the consumption, and all that. So this is information system to notify the building community on their energy consumption patterns and all that. And then marketing. So marketing is more to, it comes under the awareness training, right? Maybe the effort taken on the energy management as an energy management system and all that. And then investment. This is again comes from the top management. Is it your top management have a dedicated budget to implement this energy management system or not, and so on. Okay, so based on this, we will be giving score, right? And this score will determine at what position you are in energy management, right? For example, based on this energy management status, once I tick all the points here, so I will try to connect the line. So based on the line, if let's say my line is a just high balance line, okay, high balance line, so that means the performance is good and we just need to maintain it. If let's say low balance, so all the pillars just now I mentioned, or elements just now I mentioned, need to improve, right? And most of the time, based on my experience, for most of the building, we will be getting this unbalanced type of pattern. So this will clearly tells us that at which element we are doing very poor, which element we are doing very good, and based on that we can focus on the improvement. All right. Okay, so next I'm going to go for the roadmap towards low carbon building action plan. Okay, and before I proceed, this action plan is derived by my practice in a few buildings, right? So in Malaysia and in Thailand, in Philippines, and in Indonesia. So I have focused on some buildings on this energy management. So based on the establishing the energy management system, I have simplified the entire energy management process towards achieving a low carbon building with this action plan. So it's just 5 steps to achieve a low carbon building. The first step is set up a carbon management project committee, or sometimes we can be very specific that set up a energy management project committee, right? So normally your management, top management board or top management should be part of this, high part of this committee. Then you should have a dedicated person, like a certified person like energy manager, or maybe a green building certified person, right? And then we can divide according to each block right? So this one depend on the buildings as well. And then under the support, your human resource and also your finance team should be part of this. Because as I mentioned just now, this energy management system implementation, sometimes we need to do awareness training, sometimes we need to do some programs to create awareness and all that. So that's why it is very, very important to include your finance and also your human resource team as part of this committee. The second action plan is we need to do a proper audit. We need to do a proper carbon emission audit or energy audit to establish a baseline. Why this baseline is very, very important? Because without this baseline, it is very difficult to quantify how much energy that we have saved, right? And I don't want to go very deep into this because this is normally a half a day workshop. If let's say I talk about this part, so I'll just generally will introduce this. The second action plan is basically we should do a carbon emission audit, right? So again, as engineers, right? Just now we talk about the recent advancement in mechanical engineering. So mechanical engineering personnel should be participate in this, right? And then the third action plan is carbon emission reduction measure. So once we're done with the baselining, the next will be what are the steps, what are the action plan we should take to reduce the energy in the building. A typical energy management plan is 3 years. Just now I mentioned, right? The typical energy management plan is 3 years. Normally in first year, we will focusing on no cost measure. So that means we try to take the effort without spending much money, right? And then second year, we can focus on low or medium cost measure. So that means we need to spend some money. And finally, the third year, high cost measure, right? So of course, energy saving cannot be achieved, okay? Cannot be achieved without spending money. So I'm talking about the significant energy saving cannot be achieved without spending money. Again, we need to see in the point of view of, if let's say I'm spending, what is my ROI and all that, right? So that's where these high cost measures should be looked at. And then the fourth action plan, which is very, very important, the human capital development. Human capital development. So we need to identify the building personnel who will be in charge for this energy management drive, and we need to train them. Or sometimes we also can focus on the internal trainings, external trainings, and certification. So in Malaysia, normally we focus more towards the certification. Okay, and once the certified person from the building, he can train others and he can drive the effort of energy management. And the fifth action plan is once we have achieved a significant energy saving reduction, we should go for partnership certification and award, right? So that means after we have achieved it, it's just don't stop there. The next step is you need to promote that we have achieved this, all right? In Malaysia, normally once we have achieved a significant energy saving, we need to report to our government, right? Or sometimes we receive some what we call recognition from the government as well. Or sometimes we can go for the standards like ISO 50001. 50001 means it is dedicated towards energy management system, right? We can go for the standards. All right. So again, talking about the investment, just now I mentioned that energy management is costly, right? So in Malaysia, there are some budget allocation for this energy management. For example, our government is giving energy audit grant. To perform energy audit is not cheap. Okay, it's not cheap. To perform energy audit, it's quite expensive in Malaysia. So our government is giving some grant to do the energy audit, right? And also we are getting free certification and training, right? In fact, there also energy performance contracting scheme where, let's say I wanted to implement any energy saving measure, if let's say I don't have to invest. The service provider will be invest and they will recover from the saving that we are achieving. Maybe the first 5 years. After that, we can enjoy the 100%. Right? I believe in India also, there are many dedicated assistance from your government as well. All right. So next, if let's say you may question me, right? The 5 action plan that I have shown just now, is it just based on my theory, or is it really works, right? So shortly, I'm going to share a case study, a quick one, because we have a limited time. I'm going to share a case study, and based on that case study, actually, I worked in a way that first I practiced that, and from my practice, I derived these 5 steps, right? But before we go, let's see what's the unique selling point. If let's say for a campus to achieve a low carbon campus, so the first benefit is reducing building operating costs. When your electricity cost reduces, basically we are reducing the building operating costs, and then it will be a brand recognition. Okay, for example, one of the campus that I have achieved a significant energy saving, so we are recognized by our government, right, all over Malaysia. So it is one of the no cost marketing tool as well. And other than that, this best practice also will focus on the opportunities on collaboration with industry, other universities, and so on. And on top of that, so basically we wanted to assure a sustainable campus for the students and also for the staff who are working. Right. So now let's see the case study. So the 5 steps that I shared just now, okay, the 5 steps that I shared just now, again, is it really can be achievable? Let's see a case study. So this is based on the real project which I headed, right? Okay, first, I mentioned just now, we need to evaluate where you are. So this particular building, it's a university campus. Okay, it's a university campus. So when I evaluate where we are, we only score 6/24. So that means most of our elements are in the low end. Only the information system, we achieved score 2, right? Then once I evaluate, the next step I did was I come out with a energy policy, okay, and then I come out with energy committee. Like for example, you can see I'm as a certified energy manager. I'll be reporting to the top management, and then the facility management will be an important part of this organization as well. Then I divide this into few blocks so that we can focus on where's the energy consumption. As I mentioned just now, from the support side, human resource and finance should be part of this. Okay, should be part of this, right? And then the energy audit. Okay, the energy audit. So this is very, very important step. Okay, very, very important step. Without this energy audit, then it is very difficult to go for the energy saving implementation measures. Okay, so we did a detailed energy audit. So this is the front cover of the report. All right, then we have done the energy bill analysis. So year 1, which is, we consider this as a baseline, we have done energy bill analysis. And then normally in Malaysia, we look at the BEI. If a commercial building energy index. So how we calculate the BEI? Annual energy consumption. So energy consumption for that year divided by the net floor area of that building. So this is basically an indicator to show that how good your building in terms of energy efficiency. The lower the BEI, the better, right? The lower the BEI, the better. So we have achieved around 153.50. Then the next, we did a detailed energy audit, like we studied the electrical supply and load profile. Okay, so I won't touch very detailed into this. This is just for a sharing only. Yeah. Then we study on load apportioning. So which area of the building consumes more energy? So for example, the main building, right? Then significant energy user. So which area is a significant energy user? We have noticed that the chiller is significant energy user. Then we have studied our ACMV system. Then we also have done room data survey. Talking about the room data survey, basically we can study 3 things, where we study the temperature, relative humidity, and CO2 emission, right? And we have noticed that most of the space, it is within the range, right? And some space are very cold. So this is the space that we can target to maybe increase the temperature so that the energy consumption will be lower, right? And then relative humidity. Let's say relative humidity, if let's say it's very wet, more than 70% according to the HLA standard, if let's say more than 70%, this can cause a sick building syndrome, where it can promote the growth of fungus and all that. right? So we have noticed that, okay, there are some areas in this building is having higher relative humidity. So we need to take necessary action. Maybe we have introduced a dehumidifier and so on, so that we maintain the relative humidity in the spaces. And then room illuminants. So we measure the lighting level, right? So according to international standard, is it the lighting level is okay, or is it overlit or underlit? We notice that most of our space is overlit. So that means again there is one more opportunity to do energy saving, because most of the space are overlit. Okay, then the CO2 level. Okay, CO2 level. So normally the CO2 level should be in between 700 to 1000 ppm, or lesser than 700 or lesser than 1000 still acceptable, but more than 1000 ppm is not acceptable, because if let's say the CO2 level is more than 1000 ppm, then it can cause some other issues. Like for example, one of the classroom in the building, we have noticed that the CO2 level is almost 5000 ppm, which is very, very bad, right? And then we also did a study, and we noticed that most of the students during class time, okay, when the lecturer is teaching, they like to fall asleep. Okay, fall asleep compared to other classes. Then we take a simple step, okay, to tackle this issue, where we just improve the ventilation. So how we improve the ventilation? For the immediate step, we just open the window. Okay, of course, let's say we wanted to come out with a ventilation, it's expensive, but to address this issue, the immediate step we can take is we just improve the ventilation. And then again we perform this study, and we have noticed that the students sleeping, right, this I mentioned, right, students always like to sleep, it reduced almost 80 to 90 percentage, 80 to 90, right, 80 to 90, right? So again we can see CO2, how it can affect our students, what we call a teaching and learning, right? And based on the energy audit, we have come out with the steps to be taken, or the steps to be implemented to reduce the energy. But as I mentioned just now, normally we start with a low cost, right? If let's say immediately I ask a high cost implementation from my top management, so definitely they will ask a lot of questions, and it's very difficult to convince them. So what I did, first year I focus on no cost, second year medium cost and low cost, and fourth year I focus on the high cost. And the yellow highlighted, you can see the yellow highlighted rows. So basically all these are low cost, okay, low cost initiatives where we have implemented this immediately. And other than that, from time to time, we have conducted energy saving awareness talk, right? And then we have involved our government bodies to visit our campus, and then sometimes we do sustainable day. This is basically to create awareness among our building community. And then in terms of technical part, we have replaced, just now I mentioned, right? So most of our area is overlit. So we have replaced with a lower watt bulbs or lower watt lightings. And then the human capital development, right? So this is myself. So as a part of this practice, I am able to take some examination on the energy management, and I have become a certified energy manager. And then I drive this what we call this entire process, implementing energy management system, as a certified person, right? So this is what I mentioned just now. The human capital development is very, very important, right? And what we have achieved, just now I mentioned the year one, our total consumption is this much, right? So after 3 years, right? After 3 years, we have reduced to this much, which is almost 11% of reduction. 11% of reduction. And then our BEI, Building Energy Index, from 153, it have reduced to 136. So almost 11% of reduction in energy saving, right? Energy saving. So this 11% maybe, if let's say we convert in term of monetary, it's quite a big money, right? It's quite big money. All right. And then the next action plan, just now I mentioned that recognition. So once we have achieved that, so we get some recognition from our government, right? So to achieve this much of energy saving, and then we have invited for a strategic partnership. You can see my name here, right? Strategic partnership with our city council. In fact, our city council willing to involve in some project. They're willing to sponsor us, right? And then this is a recognition from our ministry, our Ministry of Energy and Water. So they have recognized us as well. And then again, I have a question. Okay, I was having a question. Is it the 5 steps I mentioned just now? Is it only applicable for this building, or this 5 step can be applied in any other building? So what I did was I tested out. For example, just now I was talking about the campus building, right? So I used the same approach. I test out in one of the hotel building. You can see one of the hotel building, and this hotel building we have achieved a 36% of energy saving. Then I have again implemented in one more university building. We have achieved almost 8% of energy saving. All right. So with that, I'm going to end my session, and I'm open for the Q&A. Yeah.
Thank you, sir. It was well interesting and thought-provoking session. Now I request the participants, you can raise your doubts by unmuting yourself. So there is a question in the chat box from Gopal Chandra Mishra. How energy consumption can be managed to cost per kilowatt hour in India, every household from villages to cities, in terms of practically awareness in people of India? Really, in India, we are less aware of energy management. If so, kindly suggest us, sir.
Okay, thank you for the question. So as I mentioned just now, the first thing in energy management is to create the awareness, right? So if 3 to 5% of the energy, but not change. In fact, in the change is the awareness part. So here in Malaysia, our government is very much into this energy management, and every building they should send some representative to attend some sort of awareness courses. Like for example, just now I mentioned, right? So our government have provided a grant for energy audit. So under that grant, they requested the energy consumer, which is the building representative, should attend a 5 days or maybe a 6 days training, so that they get awareness, so that they can go back and share with their building other communities as well. Right. So that is one of the important thing that we should focus, creating the awareness. And especially like for us as a university academician, so we should play a very, very important role in this. In fact, in Taylor's University, the university where I'm working, so we have embedded this into our curriculum as well. For example, one of the final year module, we have embedded this as one of the lecture, and we are creating awareness to our students as well. Yeah. So I hope I answered the question. Again, and I just wanted to add one more. So the building, the case study that I showed just now, so now I'm no longer with that building anymore. But the system that I created, which is the 5 steps and the energy management system that I have practiced, it's still there. And recently, the building have achieved almost 40% of energy saving. So that means, as I mentioned just now, it's all about the system. It's not about the individual, right? So if let's say the system in right place, then these things can be achieved. As I mentioned just now I'm no longer with the past 2 years. I already moved to a different campus. I'm working with different campus, but yet the building is continuously achieving energy saving as well. Right? I hope
we have one more question.
Yes, please.
From Dr. Neelam. How much seriously the world look after the Paris Agreement in future? What are your suggestions regarding this?
Okay, talking about the Paris Agreement, it's actually one of the serious things that every countries are going towards it. And initially, the goal was until 2030. Like for example, in Malaysia, by 2030, we need to achieve 45% of carbon emission reduction. Right, and Malaysia is accelerating our effort. I believe India also doing the same thing. So the Paris Agreement is one of the, I'll call one of the important target, right? A target that promoting this energy management, promoting this low carbon initiatives all over the nation, all over the country, all over the, in terms of globally, this Paris Agreement is the first thing that promoting this, all these sustainability related efforts. So this is something very, very serious, right? So most of the countries, most of the countries is part of this Paris Agreement. It's to answer the question, yes, most of the countries are looking this Paris Agreement very, very seriously.
So, any other questions from the participants? You can raise your doubts. You can unmute yourself and you can raise. So, thank you, sir. It was quite interesting session. You have touched upon sustainable developments, the low carbon building, green building, and sustainable energy management system and its roadmap, and the evaluation of energy management system using rubric methods and a roadmap towards low cost carbon building and its 5 action plan. It was quite interesting. And also you ended up with a case study. And also you have shown few slides about your programs and the sustainable day celebration. So we also, from this session, we can also think that we can also follow this sustainable day in the coming future. Thank you, sir. Overall, it was a thought-provoking and enlightening session. Thank you.
Thank you very much, and thanks for the great opportunity. And I'm happy to share this awareness. Basically, this is an awareness session as well. The awareness with you all. Thank you very much, and please feel free to contact me if, let's say, you wanted to collaborate or you want any advice from me. Please feel free to contact me. Thank you very much. Hope to see you guys in our upcoming session.
Thank you, sir. Now I invite Professor Dr. P.S.N. Raju to give vote of thanks.
Thank you, sir. On behalf of the management, principal, vice principal, and Department of Mechanical Engineering, Swarnandhra College of Engineering and Technology, Narsapur, Andhra Pradesh. Sir, we extend our heartfelt gratitude to our today's speaker, Dr. Nagendrahu Muniandi, Senior Lecturer, School of Engineering, Faculty of Innovation and Technology, Taylor University, Malaysia, sir. We have shared his expertise in this knowledge sharing platform on the topic energy management. Sir, your session was incredibly.
All the participants, the feedback link is posted in the chat box. Please go through it.
Sir, 5 minutes so we'll start. Good evening, sir. Dr. Palinipan, sir. 5 minutes after that, we will start the session, sir.
Okay, fine, it's fine.
Sir, welcome, sir. Good evening, sir.
Yeah, good evening.
Swarnandhra College of Engineering and Technology. Unleash your potential. Build your career here. Godavari Delta in Andhra Pradesh, with its finest soils and pleasant waters, is the richest region for its age-old traditional and cultural heritage. The Vashishta Godavari, a tribute of river Godavari, flows fluently with all that vibrant erudition spreading along its banks.
Our college was established in 2001 by the Vashishta Education Society to produce global, competent and dynamic professionals, creating Center of Excellence in Technical Education for Empowerment. Apart from curriculum, we train in the latest technology like data science, VLSI, Python, full stack, Java full stack, SAP, process integration, ABAP, FICO and ERP.
Swarnandhra College of Engineering and Technology in Narasapur of West Godavari, vicinal to Vasista tributary, carries the baton of such a rich heritage with its dedicated efforts and support in imparting up-to-date, latest, ultra-modern, futuristic mode and phase of engineering education and tech knowledge.
We at Swarnandhra give importance to intersection between theory and practice, passion and present for good technical and practical knowledge. It makes our children ready for the industry.
With its more than 2 decades of untiring and uncompromising quest, empowering the next generation of engineers, Swarnandhra College of Engineering and Technology had unleashed the potential of thousands of enthusiastic students with its engineering program. Yes, Swarnandhra College of Engineering and Technology is pushing the boundaries of technology. Are you ready to join it? Do you want to forge your own path with its top-notch engineering curriculum? Don't you want to be part of a community of innovators, creators, and problem solvers?
Swarnandhra is a place where thinking out of the box is contagious, and it is also a place where ideas inspire change.
Here you are welcome to the prestigious Swarnandhra College of Engineering and Technology, where excellence meets innovation.
Swarnandhra College of Engineering and Technology is a well-maintained...
Now it's my pleasure to invite Professor C.H. Harish Kumar to introduce our today Day 2 Session 2 resource person. Sir, please.
Thank you, sir. Good evening, one and all. I am happy to introduce our today's guest, Dr. P. L. K. Pallayappan, who has obtained his BE degree in Mechanical Engineering from TCE Madurai, Kamaraj University, and ME degree in Production Engineering from Annamalai University, and PhD in Mechanical Engineering from Madurai Kamaraj University. He has been working in the Department of Mechanical Engineering of Tyagaraja College of Engineering, Madurai since 1997, and presently is working as a professor in the same college. So Sir has published more than 50 papers in international journals and attended many of the conferences. So Sir is also a reviewer for the various international journals. So Sir has guided more than 6 PhD scholars and also guiding 6 more scholars under his supervision. So the PhD scholars have done their research in the areas of marine logistics, logistic optimization, service supply chain, healthcare supply chain, and manufacturing optimization. So Sir has successfully completed 4 consultancy projects and 3 sponsored projects. So he serves as an expert member for AICTE and MBA. So Sir is a life member of ORSI and ISTE and IIPE. So Sir's research interest includes operations management, supply chain management, and manufacturing optimization.
Thank you, sir. Now I hand over the forum to our today resource person. Sir, please.
Yeah, good evening to one and all. Am I audible?
Audible, sir.
My slides are visible?
Visible, sir. Visible.
Yeah. So good evening one and all present here. I'm happy to join in this forum to discuss about the additive manufacturing in circular economy. So this particular topic is a very hot cake today because the sustainability aspects are getting very much importance in the today's competitive world, and to be in leader in sustainable environment, the circular economy aspects are brought in. So I have made my presentation like this. First, I will give you the motivation. What is the motivation behind this topic? Why I have coined these two words? That is additive manufacturing and circular economy together. And we are going to see about the various additive manufacturing processes available today and how this additive manufacturing evolved. And a very important topic of today, the role of additive manufacturing in circular economy. That is how it enhances the circular economy. Then the types and technologies involved in additive manufacturing and where this additive manufacturing is being applied. Various applications, very interesting applications are there, and of course the advantages what we are going to gain by this additive manufacturing, implementing additive manufacturing concepts in today's scenario that we are going to see. Then finally I am going to conclude with the current trends in additive manufacturing which favors the circular economy. Okay. So my voice is clear. I mean, can I continue or whether I have to adjust? Audience, please, anyone respond?
Sir, audible, sir. Which screen also clear, sir.
Thank you, thank you. So the slide, what you are seeing here, it is a 3D printed post office, first of kind in India. Okay.
Sir, excuse me.
Hello.
Sir, slides not moving, sir.
What about now?
Still it is in first slide.
Is it moving or not?
Not moving, sir.
Again, I will do represent again. Is it moving now?
Sir, screen not shared, sir.
Okay.
Now it is slide 2.
It's moving?
No, sir, it remains in the slide 2 one. Now it is slide 5, sir.
Fine. Shall I continue? Is it okay?
Yeah, now it is in slide 5, sir. You can continue.
Okay. So the photo, what you are seeing, the building, what you are seeing is a 3D printed post office. First of kind, it was built in Bangalore. It was ready within 45 days. They are planned for 45 days and completed in 43 days. So these are the scenario in this competitive world. The 3D printing technology are the popularly called as the 3D printing technology. That is the additive manufacturing. It plays a role. So this is another one, very hot and a very new one. That is in April 22 newspaper Indian Express it came. That is for our military operations at Ladakh. live at Ladakh. The elevation is 11,500 feet. So where the oxygen is very low, in that place they have done a online printing of 3D military bunker. It was built. It's a collaborative work of IIT Hyderabad and Simply Forge Creations Hyderabad. So these are the scenario what we are facing and what we are living today. And I have shown a few additive products made at our college in our manufacturing automation lab at Theodore College of Engineering. The left one, what you are seeing, what I am showing the arrow mark, that is our college main building. This is our college main building. It was built in our FDM machine. We have a fusion deposition modeling machine by Stratasys. And the other side, on the right top, you are seeing a blade. Yes?
Slide remains in the same, sir. 5. Slide number 5 is displayed.
Is it moving now?
No, sir.
Is it moving now?
Yeah, now it is moving, sir. Slide 6. Yeah, now it is slide 6, sir.
Okay, if I go to full screen mode, it is giving some problem.
Okay, sir, this is fine. You can.
Okay, fine. Okay, so in the screen, what you are seeing, that is our college main building. It was built in our 3D printing machine, that is FTM technology. And the right hand side, we have done some live projects for an impeller blade. And this is a one chain for our consultancy project what we have received. And the bottom one, what I am showing my arrow mark, that is a prosthesis for a medical application, that is for a customized prosthesis for a patient that is being done at our lab. And now let us see what is circular economy. So most of you know about anyhow I want to just recalculate what is a circular economy. So circular economy generally it is focused on minimizing the waste and maximizing the reuse of material. So it is a sustainable approach that aims at keeping resources in use as long as possible. That is, we want to use that material to the greatest extent. That is till the end of its life. Even after once its life is over, we want to reuse it in some cases, or in some cases we may want to repair and reuse or refurbishment. Now refurbishment market is there. Even in online, many people prefer to buy product by refurbished product because of their cost effectiveness. And of course, the final one is if you cannot do anything of these three, that is reusing, repairing, and refurbishing, then the only option what you have to go is just for going for recycling. And this is a circular economy in a circle view. That is, we have energy and material as an input, and it is being this energy with the energy given energy and the material. We started our production, and once the product is produced, it is being distributed to the market, and in the market people buy and started using it. Once the material is used, the product is used, they are going for disposal. And nowadays, again, in many of the Western countries, the waste disposal is a very big issue. End of life scenario, that is people used to call end of life. For each and every product, we have standards for how to dispose that product. The end of life criterion is very critical. So some of the product can be reused and some can be remanufactured and refurbished and some can be recycled. That is what we have seen in the last slide also. Just I want to reinstate what we have seen in the last slide. And finally, if you cannot do anything, then it goes as a waste and emission leakage. So the last one that should be avoided as maximum as possible. That is the principle of your circular economy. And nowadays, now the traditional way of looking at our economy is it's called as a linear economy, where we are going to take the material and we are going to convert that material into useful end product, that is taking the material and making the product, that is make and dispose. Once the product is used, just we are disposing. We are not recycling. We are not going to have a rebirth or reuse of that material. So entirely what happens, all disposed materials are being dumped in the mother earth and our earth is getting polluted. Again, pollution and disposable problems are increasing and it becomes a very big issue for almost all the countries. So that's why this circular economy, all the world has turned their eyes towards this circular economy. That is, we want to make the product, use the product, and try to recycle the product as maximum as possible. So circular economy in practice, we are not talking circular economy in the principle, it is being in practice also. So we all very well know about that IKEA. IKEA is a manufacturer, furniture manufacturer. They have their presence in all over the world. So they have implemented a program called Take Back program. That is, they will take back the used product, used furniture, and they are going to recycle it and refurbish if possible. That is what their policy. And almost they have invested the sustainable materials from forest conservation programs and recycled plastics. It is not stopped with the furniture manufacturer, even our consumer product manufacturer, the Unilever. They are also involved in ethically sourcing the product and they want to reduce the packaging. Again, another one very big wastage is your packaging. Many of the material comes with a very good, nice package. That's why it is being attracted by the end user. Consumer are very much attracted towards the method of packaging. Packaging not only safeguards your product, it also gives you some aesthetic appearance. But it should be done in such a way that the packaging should be very easily disposable, or it should be recyclable or reusable. And another one is a Daico is a Dutch company. They have done a revolutionary thing in textile industry. That is, they have gone for waterless dyeing technology. Nowadays, in many places, even in India, we are witnessing the pollution problem. That is, in many places, the water is being polluted nearby the industries where textile dyeing is happening, and as well as the leather tannery and other places. So here, this company Daico, they have revolutionized dyeing without water. And another example, practicing example is our automobile leader BMW. So they are using the recycled material in their vehicles and they are developing a closed loop systems. And of course, one good thing what we are practicing till now is the recycling of battery cases. Even our two-wheeler and four-wheeler battery, they have been recycled. The cases and whatever they can reuse, whatever recycling is possible with the batteries that is being adopted in our Indian scenario, and many of other parts we are not yet started. And Dell, as we know, another computer manufacturer in leaders in electronics, they also implemented closed loop recycling. Next slide shows about the recycling loop of IKEA. There is a furniture manufacturer. So what they are going to have, they are going to have the product in customer homes. That product is being done. That is the product which is being used at the home, that is being refurbished, and some of the products are going to IKEA retail outlets just for remodeling and reusing it, and some of them goes to the production department just for again redesigning and reusing it, and some of the product as goes to recycling just to get some materials and ingredients from the old furniture. So this is the model which is being a circular loop model which is being used in IKEA, and it has got very good success rate. And they started implementing in almost all of their factories. That's why they have taken the program called Take Back. They are taking back their old furniture and giving some incentive for the same. Hello? Yes? Okay. Next, additive manufacturing. Now let us come to our topic, additive manufacturing. So additive manufacturing is now a game changer for Industry 4.0 and circular economy. Now all the industries, we are in the industrial revolution, that is Industry 4.0. In this genre, all the data are being fetched, and all live data, whatever you are fetching by using data loggers, they are used to ensure the quality, and they are used for optimizing your process, manufacturing process or your operational process, whatever it may be. So in that way, your additive manufacturing plays a very vital role here. It is a powerful enabler of circular economy in reducing the resource consumption and boosting the business opportunities. So let us see how it is going to help and how a radical shift in production and consumption systems came. So the if you see the sustainable goals, in sustainable goals, one of the main goal is production and consumption. How we are going to how we are going to have our ethical production and how we are going to consume it. That is being in the one of the sustainable goal, and this additive manufacturing is going to support it in a very big way. And the additive manufacturing has got scope in almost all the industries, right from aerospace, automotive industries, bioprinting. Many biological organs are being used by 3D printing technology. Very simple one, day to day, what we are having is our dental applications. When you are going for your teeth, that is when you are going for root canal treatment to have a crown for your new teeth, or when you are going for a new teeth, or you are going for a 3D printing because your old teeth profile is being measured and you are going to have replaced it with the ceramic or your porcelain teeth. And the construction industry also, it have a very good presence. And construction industry, we have seen the first slide, very first in the beginning, the post office which is being constructed in the Bangalore. And another consumer goods also, many of the goods are customizable. Nowadays, jewelry is a one big business where people want to have a personalized jewelry. And of course, some of the consumer goods are your cycles and shoes. I don't know how many of you are aware of a national bicycle company in Japan. They are producing customizable bicycles for you. That is according to your body ergonomics, according to your morphology. They are going to your height and weight and other thing. They will measure your profile in a 3D digitizer, and according to your profile, they will deliver you a bicycle which is very much comfortable to you, ergonomically designed bicycle. Similarly, the Nike shoe company, they are also delivering a personalized shoes for you, footwear for you. And in education also, there is a additive manufacturing is being used as a teaching tool and fostering creativity and innovation. Whatever students comes with a new concept, that concept can be tested with by mock prototype. They want to go for a prototype just to test their idea. So for that they are using additive manufacturing. And in fashion industry, additive manufacturing is used for, as I told you, footwear, and for custom fit items also it is being used. And healthcare, apart from dental applications, 3D printing finds its applications in orthopedic applications, and even nowadays for many of the prostheses, for the especially for the accident people, those who met in an accident, they want to have a lower limb, upper limb, or whatever the body part that is being done by this 3D printing to have an exact fit. And manufacturing, as of course we all very well know, additive manufacturing has got a very strong presence. It is going to streamline the production process. That is, it is going to have a different approach That is against the traditional approach. Subtractive approach is the traditional approach. But as it is going for additive approach, it reduces waste to a great extent. And then microwave engineering in electronics also, it is being used in a very big way. And the processes we already discussed. And renewable energy systems also, especially in battery storage systems, nowadays additive manufacturing finds a very great role. And what is additive manufacturing? Some may have a query on their mind. So additive manufacturing is nothing but you have a material. That material is going to be added from one layer to other layer. That is at the bottom. You have material in the powder form. It may not be in powder form. It may be in liquid form also. You are going to add the material one layer above other layer. Layer by layer you are going to build. It is being deposited by a nozzle or a gun, which moves in the area, stipulated path. So finally you are going to get the product. So here the wastage is a very minimum. You can look at the wastage, which is against our traditional manufacturing. Traditionally, we want to make a part like this. We used to get a source of material like this. With that material, we will make all these holes by using drilling or milling or any traditional manufacturing. So here you can look at the waste, how much waste is accumulated. So here the amount of waste is very high. So that is being the very big problem of traditional manufacturing, that is a subtractive manufacturing. In the additive manufacturing, we are going to make layer by layer. This particular picture shows the single layer, how layers are built one over the other. In the right hand side, you can see only one layer. So for this one, we are going to get the product. The product, we are going to model the product, and once the product is modeled, we are going to structure the product. That is, we are going to add layers by rail, and we are going to get the final product. So here we are going to have a CAD file in STL format, and the CAD file can be imported to a CAM machine, where it is going to have, that machine is going to have all this slicing and all this STL format, and finally that sliced files are transferred to 3D printing machine, where you are going to build the machine, and finally you are going to get the final product like this. So again, this is an idea, how an idea is converted into a product. You have an idea. Once you get the idea, you are going to get a 3D model. You are going for a 3D model, and the 3D model is going to be sliced because we want to have a number of layers. So suppose if you want to have your product very fine and very precise, then you have to have slicing, very thin slices. That ensures your product is going to have very good surface finish and other things. Once the slicing is over, then all these sliced files, they are going to upload it into a 3D printer machine. On the other side, the 3D printer machine has got a material, that is a filament. Mostly this follows the fusion deposition modeling, where we are using the raw material in the form of filament. That filament is available in the form of coils, and the coil is being supplied from the coil. The material is being supplied to the nozzle. You can see here the nozzle, and this nozzle is going to move. As it moves, it is going to do the printing job. Once the printing is over, the product is being removed, and in the post processing, whatever supportive material, suppose you want to have a hole in a particular place, that whole place is being occupied by a supportive material, not the built material. We have two materials. One is the built material, other one is the supportive material. We will see that one in the later slides. So this is the evolution of 3D printing, how 3D printing evolved. Actually, the first 3D printing concept was introduced in 1980, and nowadays in 2020, we are able to see it is being used in food, buildings, and homes and schools, and any places that is being used. That is today's role of 3D printing. And the 3D printing moments. So nowadays you can see the latest innovation here is you have a 3D printing lithium ports for the Dreamliner 74G Boeing aircraft. So in the Boeing aircraft, even these 3D printed metal parts are used as a part itself. And if you look at some year back, 10 years back, a baby life is saved by 3D printed splint by University of Michigan. So we have very many moments in 3D printing revolutionary technology. And we have two words, that is a 3D printing and additive manufacturing. These two words are being used interchangeably. The difference between them is very subtle. There are not much difference. 3D printing is generally it's a consumer grade printer, like our 3D printer, like our printer. What we have printer in our home, it is like a printer, very small equipment. You can do our small product printing. There is a consumer grade printer. It's a small scale production, and you are able to make our creative idea, all our ideas can be converted into a model by creating models and prototypes. For this, we have been using this 3D printing technology, and if you want to use it in a very big way, by industrialized way, then that is called as additive manufacturing. The additive manufacturing is a broader term. It includes a wide range of technologies and materials. It is being used in almost all the industries, right from aerospace, automotive, healthcare, and we have seen construction industry, in all medical field and all the field. So it involves advanced technologies and a professional grade equipment. Here the equipment is going to be a professional grade. Here our equipment is going to deliver you a real-time product, functional product. It can produce a very complex parts. You can scale up your production, that is, you can go for a large scale production, and it can be where manufactured part can be straight away used in real world applications. Unlike your 3D printing, in 3D printing mostly it is being used for mainly for proof of concept. Suppose if you are coming out with an idea, whether that idea can be implemented, you want to have a proof of your concept. For that only we have been using this 3D printing, that is a consumer grade. Whereas additive manufacturing, it is a real-time product you can make. So many wider techniques what we are using in additive manufacturing: electron beam melting, direct energy deposition, selective laser mulching, and laser metal deposition. These are the very new techniques which are being added here. By using these techniques, we are able to get a industrial grade products are being used, and you are able to get a load bearing parts. That parts can be straight away used in real time environment. Okay. This is a timeline of 3D printing in medical field. So again, this 3D printing is very widely used in healthcare sector also. That is in medical printing. So that is they have printed many bio parts. Many bio parts are being printed, and nowadays the era is personalized medicine. People are going for personalized medicine and personalized medical care. So for that they are going for this 3D printing, and the first commercial 3D printing for full human tissue. There is a full human tissue that is being achieved in the year 2018 itself. And this particular slide shows about the classification of additive manufacturing. So how it is being classified. So the generative technology, that is the additive manufacturing. So we are classifying into dimensional orders. There is a point, line, and planes. If we take point by point, that is in point dimensional order, the process is an inkjet printer, like our traditional inkjet printer. Here it is going to deposit the material as a point. So it is going to build the material point by point. So it is a very slow process, and it is not much in use, but it is a very cheap process. It is being mainly used as a have a proof of concept. If you want to check your concept, you can have a proof of concept tool. And another one is a line. Here the material is deposited as a line, one layer over the other layer. So here in this technology we have a selective laser sintering and your extrusion free forming. Again, selective laser sintering we have powder based, and extrusion free forming we have paste to paste and wire. These are the starting material. And another one is the plane. You can have one plane over the other plane. This is a very fast process. Here the build speed is very high. In this one we have a stereolithography where liquid polymers, epoxy polymers are being used. And another one is a laminated object manufacturing, where a sheet, it may be a paper, or nowadays even the foils, metal foil sheets are being used. You can build the parts in a very short span of time. So now we are going to see how this additive manufacturing is associated with circular economy. Okay. So these are the two concepts. Now you are aware of this additive manufacturing. Earlier you have seen what is a circular economy. That is nothing but we want to reuse or recycle our used parts, or we want to use our parts to the maximum greatest extent possible. And additive manufacturing is a technology. Here you are going to build the parts by layer. That is, here the waste is being minimized. So this is the one aspect where these two principles are coming together. And 3D printing. So very often people use this word 3D printing and additive manufacturing as a synonym, because the principle is same, only the scaling and the speed and the technology is little bit updated in additive manufacturing. So here it involves creating object layer by layer. As we are going to build the object layer by layer, the wastage is minimized. And as the wastage is minimized, we are reducing the use of material. That is also one of the very principle of your circular economy. That is reduce, reuse, recycle. That is the main principle of your circular economy. So the 3D printing is being used in automobile industries. So in the automobile industries, as it is being very widely plastic recycling and 3D printing purposes, it has taken a very big lead, because it uses very less material wastage. It ends up with a very less material wastage, and you are able to get the near net shape. That means the post processing is very minimum. As the post processing is very minimum, your secondary operations are very less, and the energy spent for secondary operations is very less. That is also it is also adds value to your economy. That is, you are not spending your energy and money for secondary operations. The other sustainable things are, it also reduces the emissions. That is also a very big thing. So when number of operations are reduced, of course the emissions also reduced. The 3D printing plays a significant role in following aspects. Let us see, there are about 9 aspects are there. We are going to discuss the 9 aspects one by one. One is the design for longevity and repair. There is additive manufacturing. It is having sustainability in production, as it is having the longevity. Whatever material you are going to use, whatever material needed is used. The scrap is very less. That is the one thing. And additive manufacturing makes easier to design products that can be very easily done. When the part breaks or worn out, that particular portion alone can be rebuilt. That is another beauty of your 3D printing or your additive manufacturing. So replacement and rebuilding is very easy. You need not discard the entire product. Whatever the worn out part, that portion alone can be rebuilt. And use of recycled materials. As we have seen, many of the materials are being recycled. Closed loop systems. We have seen IKEA's closed loop cycle. The IKEA furniture manufacturer, how they are going to waste. So they are using the old furniture for that one. And another thing, some companies started using waste from landfills to reduce the virgin resources. And material innovation in 3D printing. Nowadays, very many materials are being tested, and very real-time materials can be used to build the parts. That's why the parts are ready for real-time applications. And another one beauty is you can go for on-demand production. This particular concept is also very much associated with economy, national economy, our GDP and GNP also, because it promotes localized manufacturing. That is, wherever you want the product, in that place itself you can make the product by using additive technology. So this decreases the carbon footprint. That is the amount of fuel spent for transportation that can be reduced, and to the greatest, and the amount of inventory you are going to have in your supply chain, right from the beginning of the supply chain. That is your finished goods inventory can be reduced, and the obsolescence of the finished goods inventory, there is a threat is always there because the technology is changing very fastly. Your product become obsolete at any time. So here in this one, whenever it is demanded, you are going to produce. That is called on-demand production at the place where it is being demanded. And a decentralized, there is a distributed manufacturing, that is you are minimizing the shipping. So it is manufactured at the place where it is going to be consumed by this additive manufacturing technology. And another one is the customization and efficient design. Now, with the additive manufacturing, you are able to do customized designs, efficient customized designs. As you are going for on-demand and tailored manufacturing, you are avoiding unnecessary waste and resource waste, unnecessary material waste, and it helps you to get product at a lighter weight. In 3D printing, you can have your analysis package, simulation package, ANSYS package. The output can be directly given to your 3D printing machine, and you can build the material wherever you want. Less strength, you can go for alternative materials, so you can reduce the weight. That is also another one advantage of having your additive manufacturing. And waste reduction and recycling. So repurposing existing product, nowadays it's as we have discussed in the beginning, refurbished market is a very big thing. And another one thing is a rapid prototyping. That is again the order of the day. Nowadays, all the people are going for this rapid prototyping to have their new product very quickly. There is gone are the days. Some 30 years back, if you see in our Indian roads, we were able to see 3 or 4 types of cars: only Ambassador, Premier, Batmani, Plymouth, etc. So nowadays, every 6 months or even every 3 months, all the automobile companies are able to release a new version or new model or a new product. How it is possible? It's all possible because of the technology called rapid prototyping. So rapid prototyping, it gives you iterative designs in a very short period. It is able to do the iteration in a short period. That means in few hours you are able to make a prototype. Earlier, for making a prototype, the average time spent by automobile industry is about 2 to 3 years. Now the 2 to 3 years period is being reduced to few hours. Okay. So in a case study says that, and this is a case study which is being done at our place Madurai, where we have a Sundaram fasteners. They are the manufacturers of fasteners for automobile industry. So their case study says that fastener for an automobile, it took 6 to 8 months in 20 years back. Now they have done the same work. Now they are able to do within 12 hours because of this rapid prototyping technology. So that is the innovation speed, flexibility, what they have in this 3D printing. Next one is the customer participation in circular economy. Now we all very well know that do it yourself. That is the order of the day. So whatever an online product, we are getting many product in online. In many of the product, we have to do troubleshooting of our own way, because we cannot have a person for installation and self-installation and self-troubleshooting is the order of the day. So here, all the products are coming out with a pamphlet that shows how to do. That is called as a do-it-yourself, DIY. So DIY is a very big concept in Western countries, where getting a technician for installation or a small repair, household repair, it is very costly affair. So in this one also, your components or product designed with the 3D printing, they have their supporting documents and supporting reuse of their items, or the existing item is there, and the peer-to-peer sharing of designs is also very much there, because many of the 3D users open source designs, so you can get how to repair it, how to reuse it, or how to troubleshoot it. That's also aid for the circular economy. And the next one is a resource decoupling. So the additive manufacturing has got the ability to, it's a unique ability to decouple the resources. That is the personalized product what you are going to get. That is, you can troubleshoot or you can do small innovations with that itself. As I told you, because they are mainly make use of open sources. And finally, the business model innovation. So AIM is a new enablers for circular business models such as subscription-based services, where the consumers are encouraged with some incentives for subscription. So the product upgrades, replacement, and customization made easy. So this is also going to promote resource efficiency and customer retention, and finally it aids the circular economy also. And this 3D printing techniques, we have already seen the 3D printing technology based on geometry. Now this is a 3D printing technology that is on the technique. You have a photopolymerization technique, extrusion based techniques, powder techniques, and lamination techniques. This classification is based on the technique what we are using. So in photopolymerization, we are having a material jetting. Stereolithography is a very old and pioneer one, and digital light processing and continuous liquid interface. That is a clip. That is the last one. Continuous liquid interface production. That is a very new technique that is being used in nowadays by many companies. It is a very fast one. In a fast manner, you can build the product. And in extrusion based, which is a market leader in 3D printing, fusion deposition modeling, FDM machines. Almost all the 3D printing machines which are all available as desktop machines are fusion deposition modeling machines only. And another one is a direct ink writing machine. And we have a powder based selective laser sintering and selective laser metal sintering. Earlier one is a selective laser melting is a metal. This is for the polymers. And we have binder jetting. And finally, the laminated object manufacturing, which is also surface modeling based, which is also very fast. Now, this particular slide shows four main models, four main technologies, which are all used nowadays, which are all have their presence, wide presence in the market. First one is a inkjet printing. Next one is a fusion deposition modeling. Next one is a stereolithography and a selective laser sintering. So these are the four methods which has got very great market share in additive manufacturing. The first one is a inkjet 3D printing. Inkjet printing, like our inkjet printer, you have a binder that is going to be deposited in the areas where you want to build your parts, and the powder is being deposited on the binder material, and it is going to have a layer. The layer is being built. So by the way it is being built, it is a 3D printing. So this particular slide shows how the material is being built. Now the second middle one, you can see the area which becomes a part. Now the this binder is being there, and here the inject head is going to pour the material powder, and the material is being built. So this thickness is very minimum. It is being exaggerated here, but the layer thickness are very minimum. It's in microns. Next one is a fusion deposition modeling. It is a very, as I told you, it is a very popular, very widely used. Here you are having an extruder. The extruder can move in XY plane, and your nozzle can move up and down in a Z direction. So by the way, you are able to produce a 3D product. So this is the schematic diagram of your machine. So you have a computer connected to the machine. So this is the machine. So this diagram also shows the status machine. The similar type of machines only we have in our college. So here you are having a filament supply that is being done in a filament cartridge tank. From there the filament is being supplied, and this is a nozzle. In this nozzle you have heaters. So it is going to melt the filament, and the filament is being deposited in the place where we want to have. So this table can move in X and Y directions, and this nozzle can move in Z direction. So by the way, by moving all table and the nozzle is being moved for layer thickness, and this table is moved to have a product configuration. And wherever you want to support material, it builds support material. Wherever you want real product, the nozzle supply built material. So the nozzle can supply built material as well as support materials. So the common plastics which are all used in FDA machines are PLA, parallel acid, ABS, acrylic butyl styrene, and PTG and nylon. So many of the machines are using PLA and ABS nowadays. Next one is a stereolithography. It is popularly called as STL or SLA. So this is a RP process. It is mainly used for rapid prototyping because this particular technology is being used in many industries just to have test their prototype. They want to make a prototype and they want to test their prototype. They want to do it in a small time frame. So the first commercial printer available in the year 1988 by Charles Hull, that was the first commercialized 3D printing machine based on stereolithography. In stereolithography, it is going to build the product by layer. So here you have a liquid polymer which is being in a tank, and here you have a laser which is a photo. It is going to photo curing. So the layer is going to be exposed to the curing. Wherever it is being exposed, that part gets cured. Once it is cured, it is moved down. So this movement Z axis, as the part builds, it moves down and down. So when it comes to the bottom, your entire product is being built. So when this tank reaches the bottom, you are able to build the entire part. So this is being the technology used in stereolithography. Again, the same stereolithography. So the curing can be done by many sources like UV light or laser. We have, depending upon your material, it changes. So now this selective lasers. Next one is the selective laser sintering. Next to stereolithography, we have selective laser sintering, where the powders, either metal powders, nowadays direct metal powder sintering is also available. That machines are very costly. That is being used in industries. And the selective laser sintering, where we are using the polymers, it is being used in research institutions and educational institutions. It is being again used as an equipment for making prototypes. Here a layer is built. Once a layer is completed, the loose powders are being sintered. It is like applying heat, and we are going to sinter the powders, and powders are solid state welded, and you are going to get the product. So this is a selective laser sintering. Here you are having two cylinders. One is a powder feed cylinder, and another cylinder is a part built cylinder. So here, once the powder is feed, the roller mechanism is going to roll out the powder, and it is being come to the built cylinder, and it is being deposited over there. And by the way, the product is being built layer by layer. So this process, it is being used for metals as well as non-metals, as I told you. Polymers like nylon, metal, glass can be built by using this. Even nowadays, people are having composite materials are being built using this selective laser sintering. They are being used as a functional prototype. That is a very important. So functional prototypes are very much required, because people, gone are the days people are not satisfied with the physical prototypes. They don't want to stop their testing or validation with the physical prototype. They want to have a functional prototype to use the prototype in real-time environment. So functional prototypes are being built with the selective laser sintering. You are able to sometimes you can get end-use parts. If number of parts are required is very less, it is better to go for additive manufacturing. Additive manufacturing will be economical rather than going for a conventional method of producing the parts. So that is, when the part is required in low volume, nowadays additive manufacturing is being preferred. So this is a selective laser sintering machine. You can see the part being built by them. So this is again Azum.com. So there, how they are going to have scanning directions, and how the powder is being fed from the left hand side, and the bed will envelop in the middle, and the powder feed cartridge is at the right side. Another advantage of your selective laser sintering is direct metal sintering. As I told you, even metal powders can be fused, okay? And you can get a prototype in metal itself. So you are able to get a fully functional product. So fully functional product can be manufactured by using this direct metals laser sintering, so that you are able to get a fully functional product which is a heat resistant, strong and durable, as good as your original product, because you are going to use the original material. Whatever the design material, that material can be used for this one. Okay. So this is a direct metal sintering setup where you are having a scanning mirrors and laser beam and a sintered part, and you are able to get a powder bed and the sintered part on this side. Now, almost all metals and alloys can be built using this direct metal sintering. You can build the steel, titanium, even high temperature metals, high corrosion resistant metals like cobalt and chromium can be built by using the direct metal sintering. The applications, complex metal parts can be made by using this one, which are all being used in aerospace industries for aero engine parts. Many of the aero engine parts you need either nickel cobalt or chromium cobalt alloys that can be built using this direct metal sintering, where you require low numbers. Why I am taking the example of aerospace? In aerospace, we are not going to involve in mass production. In aerospace, we are going to build a very few numbers. You can count the numbers with our fingers only. So suppose we take the Boeing, they may have a target of building less than 50 numbers of aircrafts in a year. It's for such a low volume. If you want to build a very minimum number, low volume, this is direct metal sintering is taken as a competitive option. Advantages of direct metal sintering. So this method is you can manufacture most complex elements, whatever may be. Even you can reduce the production cost also, because you are not going to invest your cost on tools and dies, because tools and dies are going to be very costly when you are going for traditional manufacturing. Even nowadays, fixture is also very costly. So direct metal sintering technology is combined with the topological analysis that enables the manufacturer lighter than those of originating from the conventional manufacturing. That is, you can go with the weight reduction. That is very much possible with the direct metal laser sintering. So the weight to durability ratio is very high with the DMLS parts. Suppose your product is made up of this technology, the weight to durability ratio, because it is going to be lightweight, and you can do high resistance, corrosion resistance metals such as 316 stainless steel, 316 L2 steel. There is an alloy of stainless steel which is being used in medical industry and aerospace industry, and aluminum alloy and titanium or inconel alloy, which is going to be very hard and high temperature applications, that can also be made by direct metal laser sintering. And next one is a laminated object manufacturing, which is a cost effective. It is generally used for proof of concept, where you are using papers, plastics and cellulose materials or fiber reinforced materials. In this method, you are going to build layer by layer. Here, the only advantage of this method is you can do it in a very quickly. So this is the thing. So we are having a laminated object. We are having a sheet stock, and the laminated block is being built at the building platform. On the right hand side, you have a supply roll, and left hand side, you are having a take up roll. And once the parts are built, the built parts are removed. and taken up for use. So again, this is a product made up of laminated object manufacturing. This laminated object manufacturing is generally used as an proof for physical prototype, where you want to have a appearance and feel of your product. So now we are moving on to the applications of 3D printing. So 3D printing, as I told you, it finds its application in almost all the field. It is finds application jewelry, culinary, that is for in kitchen also, orthopedic, in medical, especially dental, again separate medical wing, and breadboarding in electronics, and general for any design, that is for rapid prototyping, and in industries it is being used to manufacture many products. There is a direct production. It's also possible with the 3D printing technologies, and it finds in application in engineering design, consumer product.
ஏசி கிட்ட போப்பா.
Hello. Will you please mute? Okay, fine, thank you. It is being used in education, aerospace, medical, even it is being used in movies and theaters also. And architecture people started using, we are going to see some applications in the coming slides, and fashion technology. In aerospace, lightweight printed aircrafts and spacecrafts are being used. Hindustan Aeronautics and 3D Wipro jointly they have done a blower components for Tejas aircraft by using the technology direct metal laser sintering. So just now I spoke about direct metal sintering. So they are able to achieve 50% of weight reduction compared to conventional manufacturing. You see what is the advantage of going for direct metal laser sintering. There is it also aids to your economy also, because as the weight is going to be reduced in aerospace application, your fuel cost is going to be reduced. That is going to be a perennial. There is operational cost is going to be reduced. Your material cost is going to be reduced, and it is going to strengthen your circular economy to a greatest extent. And GE has first printed 3D jet engine fuel nozzle, General Electric. So almost all aerospace companies started using these 3D technologies. And in automotives also, our Mahindra and Mahindra, they produced 200 3D printed polymer parts for their vehicle prototypes. You see the scale in which automobile companies are using. And the Tata Motors are started using selective laser sintering to batch produce plastic and rubber spare parts. And again, another one thing is, if you want spare parts which is rarely available or which is not in use, that worn out or absolute design spare parts can be made by using this additive manufacturing. It reduces cost by 80 to 90% compared to conventional, because otherwise you got to go for the dies and the tools for making that part. So this is an aircraft 3D printed aircraft machine jointly done by Wipro and Hindustan Aeronautics. Aircraft engine component made by direct metal laser sintering. You can look at the profile, how the profile is complex, how complex it is, how they are able to produce this much complexity. In construction industry, in India, they have printed houses, 3D houses, just in 2 weeks. So Chivasta is the company. They have got a technology called concrete extrusion technology, by which they are able to do this technology. The similar technology is being used in Ladakh. I showed in the first initially. That is IIT Hyderabad. They have done a joint venture in our military. In Ladakh, Leh, they built a military bunker. They use this technology. And Amaze 28 is the Kerala's first 3D printed building that was built in 28 days with 70% reduced labor cost. And in healthcare, 3D printed skull implant and 3D printed orthopedic implants that are being done nowadays. And this is the 3D printed house at Kerala, which is being built in Kerala in 28 days. It came in the year October 9, 2023 in the paper Hindu. It is being published as a very big article, the first 3D printed building at Kerala. And this is another one signature statue commemorating 75 years of India Cements in headquarters at Chennai. Again, it is being done by Vasta company by 3D printing technology. The helical design of the structure, they have done it very complex design. They have done it with the 3D printing technology. Okay, as we have discussed in consumer applications, MECH&ROBO is a company which offers 3D printed jewelry. That is customized. You can customize your jewelry according to your personal design, personal wish. You can go for personalized jewelry. And companies like Dokap, Carbon Hill, even Nike, they are also into 3D printing technology to give customized flexible footwear designs. And biomimicry and 3D printing, that is also another one area. So biomimicry, by inspiring the very biological nature beauty, many of the products are being 3D printed, like spider webs, inspired lightweight structures, lotus leaf self-cleaning surfaces, and the optimized structures are being built by using this one. And next slide shows the bio-inspired biomimicry. That's a bio-inspired claw. There's a claw, so a novel bird claw. So they inspired a bird claw, and they have done an upper limb prosthesis model. So upper limb prosthesis model was based on this novel bird claw. So how biomimicry inspired 3D products are being made, we can witness from this slide. And as we have discussed, 3D printing, the advantages of 3D printing over traditional is you are able to get a customized product, you are able to produce complex geometries, honeycomb structures very easily. Or building a honeycomb structure in conventional manufacturing is very, very difficult. You can produce your product wherever you want. And material saving, because you are going to have a filament, your raw material is in the form of filament that can be very much recycled. And this shows the advantages of 3D printing. That is, you can go for, if you go for construction, you can go for faster construction, where cost is going to be low cost, geometrical freedom you can get, and a short supply chain, because whatever you are going to have, that you can source in bulk and you can use as per your requirement, and you can have a constructability, you can elevate your constructability. And other advantages are rapid design iteration. It is being used in education and training for creative design thinking as well as spatial skills. That is, your students can test their concept, their design, they can validate their ideas, they can move apart. And it is being used in supply chain resilience also. That is, in many of the natural disasters and pandemic, the supply chain is broken. So whenever it is being broken, this circular economy encourages, and your additive manufacturing encourages localized manufacturing. As it is encourages localized manufacturing, it strengthens localized manufacturing capacity. Your disruptions are very much minimized. That means you are not only saving the carbon footprint, but you are able to meet the challenge as you are equipped to produce the items locally. So this particular slide shows very many advantages of additive manufacturing or 3D printing. You are able to risk reduction, reduce your risk. You can do rapid prototyping. You can reduce your prototype development time. You can easy to use, ready to use products are available. Flexible designs are possible. You can set your quality. You can print the product as on demand. No need to store finished goods. Okay, and you are able to get lightweight parts. You are able to bring down the setup cost, and you are able to foster your design and production. You are able to minimize the waste, and this is an environmental friendly process as it is going to minimize the energy and the carbon footprint. It is environmental friendly, and it is being used in modern medicine as a personalized medicine. And the current trends in additive manufacturing are clip technology, as I told you, continuous liquid interface production. So this technology, it aids you to build your parts in a very short span of time. Your building is done very quickly. It is being adopted in automotive and aerospace and consumer products. Unlike your traditional 3D printing, which takes hours together. So suppose a part which is being built in a FDM machine, it takes 4 to 5 hours, means the same part can be built in clip technology within 20 minutes. That's what the statistic says. And next one is the AI integration. So nowadays there is no field without AI. AI, artificial intelligence, is also integrated to optimize designs, to control quality, and to select materials. And it also enhances the efficiency and the capabilities of 3D printing. So as usual, wherever AI is brought in, it enhances the efficiency and of course the capabilities. So the key initiatives in India for 3D printing. So our national strategy for additive manufacturing. So our Ministry of Electronics and Information Technology in 2021 laid down strategic roadmap for fostering this 3D technology. The key goals are enable 100 innovative 3D printing setups, develop 50 India-centric technologies by 2025, train 5,000 skilled workers by 2024. So it seems the first goal is being achieved. That is what their website says. 100 3D printing startups already start. It is more than 100 what they say. And 4D printing and other applications, that is another current trend. Apart from 3D, now they are moving towards 4D. So 4D means your product will transform over time without the invention of human interaction. No need to be human interaction. So your product itself, like a smart material, your product itself transform over time. So that is being termed as a 4D printing. That is being the order of the day. So with this, I sum up my lecture. Thank you all. Thank you for your opportunity.
Thank you, sir.
Yeah. So this is our this is our place, Madurai. What you are seeing is on the right top is the Madurai Meenakshi Temple, and this is our college main building, Tyagarajar College of Engineering. This side you have our research center, Tyagarajar Advanced Research Center, and this is our founder, Karumuthu Tyagarajan Chettiar. So our motto is TCE, where quality and ethics matter. So with this, I conclude my lecture. Okay, thank you.
Thank you, sir. It was an interesting session about additive manufacturing and how this circular economy really useful in case of recycled materials. Now the participants can unmute yourself and you can raise your questions. Sir, I have a question, sir.
Yes, please.
Generally, in 3D printing, we use plastic materials.
Yes.
So, how about incorporating metal as well as plastic in a single machine? Is it possible?
Yes. Nowadays, it is available. We have a reinforced. That is, you can have a metal as a reinforcement material, and over that, you can have a plastic. That is a PLA or PEEK, any other material. At the center, you can use a reinforcement. Now itself, the such machines are available in the, they are in use. We have one such machine in our college also, where you can have the reinforcement from a steel wire or carbon, and you can have a other material as the plastic PLA as a covering material.
How about the influence of temperature, sir, during curing time?
So generally, the temperature is for most of the plastics, it is around 240 to 260, not more than that. So when you are going for this reinforced, for reinforcement material, the machine should have that capability of going up to 450 degrees Celsius. To 600, even some cases.
Metals having different heat treatment process till it comes as a final product. How about 3D printing material, sir? Will it be same?
What you are talking? Heat treatment after a product is made.
Generally, conventional material method of making product uses different heat treatment stages. But in case of 3D printing,
here it is not possible. It is not possible because generally we want to we are going for heat treatment. The purpose of heat treatment is we want to inculcate certain engineering properties. Here in 3D printing, according to your requirement, you can choose the material. So once you have chosen the right material, that property itself available in the material itself. No need of heat treatment. You can choose the material straight away. In direct metal laser sintering, you can bring the material, whatever, even metal powders, alloys, whatever real-time material you can do. The only thing is these machines are very costly. Their cost is in the range of few crores, 5 to 10 crores, even a smaller version.
So there is a question in the chat box, sir. For final product, any finishing operation required or not? Because a huge surface roughness.
Actually, for final product, most of the cases you don't require any secondary operation. The only secondary operation you have to do is you have to remove the supportive material. Suppose if you are having a material like your English letter T, the top T horizontal that may sag. In such cases, we are going to build up with the supportive material. That supportive material has to be removed. So for that one, we are having an agitator. You have a tank called agitator. In the agitator tank, you can put your finished part. Just it will have it has got a solution which can remove the supportive material just by agitating it, like a washing machine. No need of separate secondary operations other than this.
Okay, sir. Thank you, sir. Now I invite Professor G. Virendra Kumar to give vote of thanks. Sir, please.
Thank you, sir. On behalf of management, principals, vice principal, and the Department of Mechanical Engineering, Swarnandhra College of Engineering and Technology, Narsapur, Andhra Pradesh, we extend our heartful gratitude to our day 2 session 2 speaker, Dr. Paliyappan, Professor, Department of Mechanical Engineering, Tyagarajar College of Engineering, Madurai, Tamil Nadu, who has shared his expertise in this knowledge, sharing the platform on the topic additive manufacturing in circular economy. Sir, your session was incredibly informative, and we are grateful to you, sir, for accepting our invitation. Much thankful to you, sir, for your representation being a session speaker in this FTP. And thank you, sir, once again on behalf of organizing committee and my own behalf. I extend my sincere thanks to you, sir. Thank you all.
Thank you all. Thank you for the opportunity.
Thank you, sir. In the chat box. It will be active for the next 10 minutes. So participants kindly fill up the feedback form. It will be active for the next 5 minutes. And for day 3, tomorrow session 1 will be handled by Dr.
Professor, Department of Mechanical Engineering, IIT
IIT Delhi, New Delhi, on the topic recent trends in welding technology. And tomorrow, session 2 will be handled by Dr. Mohan, Professor, Department of Industrial Engineering and Management, Dr. Ambedkar Institute of Technology, Karnataka, on the topic recent advancements in tribology on composite material.
Thank you, sir.
Thank you all. Good night.